Hello students, welcome. Previously lesson 24, form 3 topic 2, we were dealing with the fourth aim of direct titration, which is determining the molar mass of the analyte. We have done example 1 and example 2. So lesson 25 today, we are going to start with the example number 3. So example number 3, we are told you are provided with the following. So Romeo 1, we are told solution X containing 5.3 grams of a metal carbonate, which is written M2CO3, in 500 centimeter cube of solution. Romeo 2, we are given solution Y, which is 0.5 molar hydrochloric acid. So the aim of this titration experiment is, we are told you are required to determine the relative atomic mass or the atomic mass of M in M2CO3. So the first procedure, we are told, bibate 25.0 ml of solution X and titrate against solution Y using phenolphthalein indicator. Record the results in the table below. So here we are having table of results, and volume of bibate used was 25.0 centimeter cube. So this is the titration table. We have done 3 titrants, and we are having the average titer as 10.0. I mean the first titer 10.0, 10.0, the other one again 10.0. Okay, the first question, but we are told determine the average volume of the acid. That's solution Y used. And here we have volume of acid used in centimeter cube. So we have 3 titrants here, and both of them are in the range of plus or minus 0.2. So to get the average volume of the titer, we can add the 3 and divide it by 3. So 10.0 plus 10.0 plus 10.0 divided by 3, we are going to get 10.0 still. So the unit there is centimeter cube. That's part A of the question. So we go part B of the question. We are told, write an equation for the reaction taking place between X and Y. So to go back to the information given, we are told X is M2CO3. So we are going to write M2CO3. That is aqueous, because that's solution X. So solution Y was hydrochloric acid. So we are going to say plus HCl aqueous, AQ. So we are going to get here, we are going to get 2 of MCl aqueous plus we are going to get water, which is liquid. We are going to get plus carbon dioxide, which is a gas. Then we put 2 here and also 2 here to balance the question. Okay, learners, you have to know this M2 carbonate, the valence of this element M is 1, because the valence of carbonate is 2. So when M is reacting with chloride ions, that means they are going to have MCl. So we put this 2 to balance 2M here, then 2Cl, 2Cl. Then we are going to have 2 hydrogen here. Then we have 1 carbon, 3 oxygen, 2 oxygen plus oxygen, that's 3 oxygen. So we have balanced the question like that. We go part C of the question. Part C of the question, we are told to calculate the concentration of solution X in moles per liter. So what was solution X? Solution X was the M2CO3 or metal carbonate. So we are given only, it is mass 5.3 grams of the metal carbonate in 500 centimeter cube of solution. So this is its concentration. But what we are asked is the concentration of the solution X in moles per liter. That means the molarity. So we have to go back to solution Y, because it's the one that has reacted with solution X, because we are given it is molarity here, and we have gotten it is volume also there as 10.0. So we start first of all by getting the number of moles of the hydrochloric acid, because in our case hydrochloric acid is a standard solution. So we say moles of hydrochloric acid. Moles is given by molarity. Molarity of hydrochloric acid is 0.5 times volume of hydrochloric acid, which is 10.0, divided by 1000. So here we are going to get 0.005 moles of hydrochloric acid. That's the first step that we are going to do. Next step, we are supposed to take now this reaction, their mole ratio. So the mole ratio between M2 carbonate ratio hydrochloric acid is 1:2. And we have gotten the number of moles of hydrochloric acid right now as 0.005. So that means we can get the number of moles of M2CO3. So that means we are going to say 1 times 0.005 divided by 2. Here we are going to get 0.0025 moles of M2CO3. That will be the number of moles of that M2CO3. So after that, we are going to proceed. We are going to proceed and get the molarity of M2CO3. So the formula for calculating molarity or concentration in moles per liter will be equal to moles multiplied by 1000 divided by volume used. So the number of moles is 0.0025 that we have gotten right now, multiplied by 1000, which is in the formula, divided by the volume used. Remember, the volume of this solution X was 25 because we are told by bed 25.0 ml of solution X. So we are going to divide by 25. So here we are going to get 0.1 as our molarity. So we get 0.1 moles per liter, or which you can write as 0.1 m capital liter, like that. Okay, we are done with that C Romeo 1. Then we proceed to part C Romeo 2. We are told the concentration of solution X in grams per liter. So the information given is we are told solution X containing 5.3 grams of a metal carbonate in 500. So we are going to say 5.3 grams. 5.3 grams of this M carbonate was dissolved in 500 centimeter cube of solution. Then we ask ourselves, what about 1000 centimeter cube? So we are going to cross multiply. We are going to say 5.3 times 1000 divided by 500. So here we are going to get 10.6 grams per liter. That will be our concentration of solution X in grams per liter. Then we proceed. We move to part D of the question. We are told calculate the relative, the atomic mass of M. So if you want to get relative atomic mass of M, first of all, you have to get the relative formula mass of M. Okay, if we remember, we were having a formula of calculating molarity, and that formula was molarity is equal to concentration in gram per liter over RFM. So now if we want to look for RFM, RFM will be equal to concentration in grams per liter divided by molarity. That will be the formula. Because if I multiply here by RFM and I multiply here by RFM, so RFM will go with RFM. So for me to get RFM, I have to divide here by molarity. Then I have to divide here by molarity. So that means if I want RFM, the formula for calculating RFM will be equal to concentration in gram per liter over molarity. That will be the formula. So this will be equal to, what have we gotten as our concentration in gram per liter? We have gotten 10.6. So we say 10.6 divided by, what about our molarity? Our molarity, we have gotten 0.1 mole up there. So 0.1. So this one, we are going to get 106 as our relative formula mass. So if we have our relative formula mass, we can get now the relative atomic mass. So we are going to say M2 CO3 will be having 106 as it is relative formula mass. So we don't know M, so we're going to say M, 2M plus, we know the relative atomic mass of carbon, it is here, it's 12. Plus, we are going to have the relative atomic mass of oxygen, which is 16 times 3. This will be equal to 106. So we can proceed. We can proceed and say 2M plus this will be 60 will be equal to 106. So if you want to say 2M, it will be equal to 106, and this 60 will go on the other side and becomes minus. 2M will be equal to 46. Then if I want to get M, I divide by 2, I divide here by 2. M will be equal to 23. So in case we are asked the identity of M carbonate, it is sodium carbonate, because that element M is sodium, because sodium has a relative atomic mass of 23. That's the end of our lesson.